This tutorial provides an introduction to Layer 3 or network addressing. We start by looking at TCP/IP addressing standards, and we'll show how network addresses are constructed. Before watching this tutorial, make sure you know how the binary number system works, and you can convert between decimal and binary numbers. There are two standards that TCP/IP uses for addressing. The current standard that's in use is called IPv4. Now, IPv4 is the original addressing standard, but there was a problem several years ago. We started to run out of addresses. There were so many people participating in the internet, so many devices, that these started to become depleted. And so very quickly, people started to work on the next networking standard, which is IPv6. Now, since then, there have been some sort of new inventions that have sort of kept IPv4 still running. We've found other ways to sort of enhance our addresses. And so IPv4 will be around probably for the next 5 years, but the next new standard is IPv6, although we're not going to cover IPv6 in this tutorial. In IPv4, a network address is comprised of 4 numbers. They're called octets. These are decimal numbers, and they're called octets because each one is comprised of a binary number that could be up to 8 bits. And if we have 8 bits, that means that any of these numbers here can be in the range from 0 to, and if you know your binary conversions, 8 ones is the number 255 in decimal. So any of these numbers could be from 0 to 255. Together, these 4 octets make up a network address. Now, besides an IP address, there's other information which a network device needs to participate in the internet. And so we'll list some of those here. So the first thing we need, of course, is this IP address. There's a second piece of information, and that's called the network mask, sometimes just the mask. And the mask is important, and it works with the IP address to determine if a packet needs to be sent to an external network or if the packet is destined for the internal LAN. So we need to find out if we can send that information just locally or externally. If we're sending some data to an external network, we also need an IP address of something called a gateway. And the gateway is attached to a router, and the router is going to forward these packets on to other networks. Sometimes we also need another IP address, and that is of something called a domain name server. So this is an IP address. The gateway is an IP address. The network mask is a little different. It's not constructed quite the same as an IP address. And of course, this is your IP address here. Now, a domain name service allows us as people to work with really English words. We don't remember IP addresses of websites or mail sites that we might want to visit. So often we'll make a request in English using some type of words that were constructed. This is called a URL. So www.microsoft.com, I can remember that as a person. So when we want a web page from Microsoft, we'll remember that we want to go to this address. There has to be a DNS service somewhere that will convert this English to a number that we can send our packet to. So DNSs are very important for using this type of notation. We'll talk about that in a bit. So we'll look at a scenario here where we have a machine, and a machine is looking to get a web page from a web server that's on another network. Here it's called www.games.com. We've given our machine an IP address. There is a mask, a network mask setting in this machine. This is the network mask. We won't talk too much about the mask at this point. That'll be for a future tutorial. Now this machine knows that it wants to get a web page from this website, so it makes that request in the application. Some application on this machine makes that request, and it wants to get a web page. So it constructs a question, and now it wants to send that question to this website so it can retrieve the web page. Now all it knows, all the user knows here is that it wants to get a web page from www.games.com. So the very first thing it has to do before it constructs this packet is it has to find out what the address is of this website. So it constructs another question that it's going to send out, and basically it says, where is, I won't put it all, games.com. So that's the data it's going to send out. Now inside this machine it has to have a DNS setting. So we'll give it that. And so the software in this machine knows it has to send this request to a DNS service. And the DNS address is listed here. So it encapsulates this question in layer 3 addressing. So every packet has to have a destination and a source address. And it's got a little trailer here for some error checking. Now the destination address for this packet is going to be 130.222.20.33. And it knows where to send it because that setting is inside its software. The source address is who's sending the packet. Well, who's sending it is 130.222.18.22. So that packet goes out on the local network to the DNS service. The DNS service looks at the destination address, says, that's me, so I'm going to strip off this information. I'm going to keep the source though, because I'll know where to send the packet back to. And it's going to look at this question right here. The DNS service then may have that answer in it, or it may query other DNS servers, but eventually it sends back a request. And it says games.com is at 130.300.34.22. To send that packet back to the client, it has to know its address, but it captured that in the last packet that was sent. So it comprises a packet that has a destination and a source. This time the destination is this address, and the source is itself, so it uses the source address here of that machine. So that packet is sent back to this machine. This machine now knows where to request the web page from. So it makes a question, sends the web page, but now it has enough information to go back. Complete the packet. The destination address that it's going to send this request to, it now knows is 130.300.34.22, and the source address is its own address here, 18.22. Now where does it send that packet to? Because it can't directly send it to this machine. It then has to send this packet to what's called a gateway. And so it has to have another setting inside its software for the gateway. 130.222.255.254. So it sends this packet to the gateway. Gateway is a port on a router, and the router's job is to look at the destination address and find out what network should this packet be delivered to. It happens to be connected to that network and knows that that packet should be delivered into this network, and so it sends this whole packet into the network, which gets delivered to this machine. That machine will look at the destination address and say, that's me, so I'm going to process it. I know where it came from. This is the source address of this machine here. And so it's going to construct a packet that goes back. It's going to be the actual web page information. It's going to add layer 3 information, the destination and the source. So the destination address, it knows that because it was the source address of the request that came to it. So the destination, it knows that it's this machine here, 130.222.18.22. The source address is its own address here. And again, this also has a setting inside it that tells it where the gateway is, and so it sends this packet to its gateway. The router looks at the destination, says, okay, that's bound for this network, and it gets delivered back to this machine. So that's an overall, sort of a quick overview of how network addressing works. Now, just a few questions. See if you can answer these questions. Just want to pause this video quickly and then we'll discuss it. Okay, so we've paused, take a little discussion. If a network device wants to send packets just to the local network, what configuration setting must it have? Well, if you're only interested in a local network, it must have an IP address. And that is a 4-octet number. And we'll look at how this is constructed a little later. What other IP settings could a device have, and what's the purpose of each? Well, besides an IP address, almost every device has what's called a network mask. And the mask works with the address to determine if a packet should be delivered locally or if it needs to go to an external network. Now, if we have an application that uses English URLs, for instance, it's called a canonical name like www.microsoft.com, then we need to have some type of service called a DNS service on our network that will convert this name to an IP address. And so if we're going to use this English representation of devices, we need to know the DNS address. If we want to work just with IP addresses, we don't need this. So this was our third piece of information. That's optional. If we're sending packets to external networks, we must have the gateway address. The gateway is attached to a router, and that device is crucial for sending packets to external networks. So if you're sending to external networks, you must have a gateway, a mask, IP address. If you want to use English names like this, URLs, you must know where your DNS is. So those are the 4 pieces of information that typically every network device will have for layer 3 addressing.